Hello there guys, welcome back to the e-bike repairs YouTube channel. My name's Dash and I take apart and I fix super fun and exciting stuff. I've got in today this, I say this, you can't see all of this yet, I'm getting there. It is a electric forklift type battery. There we go. This thing, I've just bought it. It is a Doosan. No sticker. Where's the sticker? Is it on this side? No sticker. Oh well, that's boring. Electric pallet jack. So, hopefully, after I've done this, I'm going to film a clip on the pallet jack itself. But this is the battery pack from it. What seems to be occurring is no power is coming out of this to the forklift. Now, the chap who had it before me has done a little of digging because he wanted to fix it, which, you know, fair enough. He's bypassed the BMS and he got the thing to sort of turn on, but then it was throwing a CAN bus code. I think I know what one of the issues is. We'll see. I'll get through it. So it is I don't know how well you can see that. Hopefully you can see that. 24 volt, 20 amp hour lithium pack. He's added these wires on to bypass the BMS. We don't want those, so we're going to get rid of them. We're going to put it back to how it was, hopefully. He's done some things to the BMS. We've got our big discharge plug here. Two lovely great bullet connectors. 1, 2, 3, 4 pins for the CAN bus. CAN bus connections that go between this and the, well, we think CAN bus. This and the, what do you call it? I was going to say scooter. Forklift itself. I've got the rest of the BMS here. I've got its screws and, oh look, there you go. Hangzhou NEGT Co. 7S 20 amp hour BMS 2019. Charge A, B, C, D. B to load, charge, load, B, whatever all that means. It says things. That would normally have been a top set BMS, but it's not. For whatever reason, it's just, it isn't. Now, looking at the old potatoes and meat of the matter, we've got big fuse here, BMS here, battery packs here, discharge wires. In between, things have been added. Things that were not supposed to be added have been added. So, let's get these battery packs out and I'll show you what I'm pretty sure the problem is. See, this foam is so very attached in there. There it goes. And the reason I think it's so very attached in there is because, oh, also gore warning, obliterated my thumb on a cassette earlier. I was taking the tyre off a bike and some ridiculous person decided to just smash their thumb straight into the cassette and it ruined my skin. It's not good. Right, other side of the battery pack over here. And there's its phone there. Never going to use that ever again. Okay. BMS, oh, lots of tape. Lots and lots and lots of tape. Okay, so, just throw that in the bin. If you look at these packs, these LiPo packs, it's a 7S setup, so 7 groups, 20 amp hour. So these would be 10 amp hour cells each. 1, 2, 3, 4, 5, probably 6 in this side, so 3 cells. 3 S2P in this group. And this side, there'll be 4 S2P. That one's nice and straight. Look at this one. He's puffed up like a... he's hugely puffed. It's bad. It's going to go boom. So I'm thinking what's actually wrong with this is we've lost a cell. It's puffed. That's why it's not working. Because these are just LiPo cells, I can replace them with 18650 cells or 21700s and it'll work. I've just got to undo the things that have been already done. So, there should not be these wires. These two have been added on, not meant to be there. So our first task is to remove them and then hopefully once they're off I'll be able to get a bit more of a looky look at what's going on here. These are our comms wires coming out of here. You'll have to excuse the back of my head. I'll put my hood up so you don't even have to look at my hair. How about that? There you go. I see key power, can low, can high. So it's labelled up as can, basically. We've got can. It might all be alright though. Let's see if my soldering iron's heated up. That looks kind of warm. Take the load wire off first, probably. And to do that, we'll need a little bit of solder. I had a stick of solder kicking around, but I lost it. Oh, found it. I got it. It's just there. It's going to get very warm. It's going to burn my little hands. Get a bit of... Yes, warm up. Am I pretty warm up? Oh, dripping solder. There we go. That's off. So that one of them's out. Should we just remove it entirely while we're here? We probably should. That is that one there. Oh, and annoyingly, the best part of all this is I saw this one. Oh, look, all this nice free, thick silicone wire I've got. Oh, it's good lengths. Gonna definitely keep that. Right, and then we've got our thing that's bypassing the BMS here, B minus. Well, it's attached to the B minus. And that's off. Now that was nice and easy, that was. So we should be able to pull that out as well. There you go. Look at what nice wire. I'm a happy boy when I get nice free wire. Do like it. Do we want to get rid of this massive solder blob on the back of this board? Probably. There's a couple of those. Ooh. Oh, the air compressor. Okay, the air compressor has stopped compressing. So I'll just remove some of the excess solder off the back of this board. So the back of this board looks as though it may have suffered slightly. Something's gone on here, look. Exploded traces, big blobs of solder. Shorting things out there. On the can lines, maybe. Something's not right there. I'll need to pick at that, but I really need to disconnect the cells before I do that. So let's disconnect BMS A. And let's disconnect BMS B. And let's disconnect can. And let's disconnect... What is that? What are you and where do you go? Ah, something to the charge port here. C power charge, something to the charge port anyway, just there. Let's get that off. Tweezers. Well, that's never been off. My goodness. Please don't rip out the tiny wires. There it goes, freedom. Okay, so that doesn't look too happy there, does it? Whatever's gone on here, has it gone through the board? What's supposed to be there? Ah, okay. The chap said he replaced this component here, whatever that is, a Morn Sun something. So I'm guessing that's where he's replaced it. Yep, there's, yep, that'll be fine. That'll be fine. I don't think there's actually anything else in that area. Hopefully, that's not going anywhere important. Hopefully, we'll find out, won't we? Because maybe that will ruin the whole thing. What else? He's replaced these 3 MOSFETs here for 5 of the MOSFETs. I don't really know why, and to be honest, it's not the best job in the world. But that's fine. It's all solvable. It's just, you know, it might need touching up. They're probably making a connection, but we'll see. Let's tear apart these packs, shall we? See what we've got going on. Because what I want to do is replicate all of this with 18650s or 21700s, which will mean finding whatever sort of BMS-y thing goes on in here and replacing it. I doubt there's CAN here, it's probably just cell taps, but we'll have to have a bit of an investigate, don't we, and see. So that's that off there, that off there. Do I have enough slack on these to lift it up? Not really, no. What if I did this? Health and safety. See, bat A, let's look at this one first because it's going to be easier to get to. We've got our power, in, out, whatever. This is just hot glued on. And then we've got this big boy here, which will need to come off. Where's my tweezers? There. And we've got our temp sensor. I don't think there's any logic on this board. Hopefully there isn't, and I can just use the cell tabs. There we go. Yeah, it looks as though this is just a simple board. Now, there is a thermistor that goes all the way down here. How far down does it go? To remove some heat shrink and see. I don't really want to get the knife involved if I can avoid it, because lipo. I can't avoid it. It didn't take me long to get to that, did it? Stick a knife in it. Oh, pocket deuce. Sorry if you're going out of frame a bit. There's a lot of battery and not a lot of work surface today. Get off my tweezers. How far down do you go? Just stop existing. There. It goes to there. Okay. Captain tape off. There's our little temp sensor there. Poking around. Will it come out? Oh, beautiful. Right, that's one temp sensor, so that's one thing we don't need to worry about. And then we've got our power wires. So, this wire here, I believe, just joins the two packs together. That's just a series connector. And this says NL242 DLB2P7S. So I think this is just a custom circuit board for joining these LiPo cells together. Don't think we're looking at anything too crazy. Hopefully, no logic on this, because I don't really want to have to get all these cells off there. LiPo cells are notorious for being a right pain in the arse, in the backside, in the posterior, to do anything with. Yeah, there's no logic on there. Excellent. So these are literally just going to be cell taps. So if we've got 3 groups of cells here and 4 wires, that's one off every single one. So maybe it's labelled on the BMS what exactly it is. But let's remove some of these. There's A and there's B. Okay. Yeah, it just says B+, B7, B6, B5, B4, NC, NTC, ground A, common, B3, B2, B+, B-, NC, NTC, and then ground again. So I'm thinking this is going to be pretty easy, if it works, of course. So let's get the main power removed first. So this will be power, the main negative of the pack, I believe. Is this main neg? BA? Yeah, main negative from the pack that goes to the BMS. Let's get that off. And see what goodies lie underneath. Without shorting it out, Stash. Without shorting it out. It's so heavy and difficult to move. Please don't burn my fingers. Please don't burn my fingers. There it goes. Right, so our power out is safe. It's safe. Okay, that's just normal stuff there. Let's get this big wire desoldered because I want to keep it. I like it. And then we'll take that up while we're working on the other pack. Don't short these out. There we go. That's one pack free. Get a bit of tape on that, because that could short out something, and that's not a thing we want to happen. We'll just pretend that's good enough. Right, now onto this thing. I think we should cut these cables, cable ties, because they're annoying, and I like to look at the wires. Right, this one with the puff cell, you know, there's a limit to what I'm going to be able to do. It's just it's puffed, and as much as I would like to keep it contained, I can't really. I need to get to the bloody thing. So it's one of those it is what it is kind of moments, really. Right, let's get that big one out. That's the series connection that goes to the other pack. Get that out my way. That right now is the scary one, and this will be our main positive here. Yeah, this is just a big bike battery split into two parts. It's not even that bad. I want to take off as little heat shrink as possible to keep this cell under compression. I don't really want to go splitting the whole pack if I can avoid it, because that cell, I have to dispose of it obviously, but it's going to be a right pain in the bottom. The puffier it is, the badder it is. Okay, I think I should be able to get to everything I need to get to from here. Just have to do a bit of not so careful slicing of some tape. Let's get that off. There we go. Now, will this just pull up like the other side? I don't want this to snap. That's the main thing I don't want. Oh, 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 yeah, easy. Easy stuff. Good. Get that out of the way. Right, this will be a charge wire. It is indeed a charge wire coming from the charge port, which is up here, which is a fun one of those things. Some kind of connectoid. Right. Let's have a bit of a slice of this. Oh, beautiful. I'm good at this. Like I've done it before. Handsome and modest, you say? Well. Right, let's desolder this one because it's dangerous. Hot, 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 hot. Don't short out on anything. Nice and gentle with the solder blobs. Very good. I shall keep that as well. I like that. And then let's spin you, and we'll do solder. This is just our main positive that goes out, so non-BMS controlled, this one. And our charge port cable here. It's going to get rather warm. We'll try and lift them both up together. Beautiful job, Dash. Problem is that they're stuck together now. Well, they will go together when they go wherever they're meant to go, but it's got to go up there. It's got to go that way. And then we should be free. We should be free. We're free. We finally have an empty case. Isn't it pretty? Just sweep these things directly into the bin because we don't want any of that. Okay. I was thinking, if this BMS is unhappy, I could probably run another BMS in parallel to this one. So double up all my cell voltage wires, double up my temp sensors, double up my powers in and out, maybe only use this for charging, and then use the CAN signal from this to go to the thing, and keep the BMS power going to the forklift, going off the other BMS. So some thoughts we've got going on there. Relay coil, aux 24 volt plus, not populated. Yeah, right, now that's off there, I might be able to give you a bit of a close-up of this board, for anyone that's interested. We've got, here we go, BMS 24 volt EFDM1, final 2019 1008, B minus, charge minus, load minus. Very much an e-bike BMS. Look, we've got all our little balancing resistors and things. They might even be little LEDs here on the board there. We've got our charge something pins here. Key power 1, key power 2, CAN low, CAN high, B plus, B7, 654, NC, NCT2, NTC2, so that hopefully will be for the thermistor. B3, B2, B1, B minus, NC, NTC1, ground A. Now, on here, on one of these boards, what have we got going to it? Yeah, look, we're missing a pin on all of these. So we've got our, what's this one? This one is BMS B. So if I plug BMS B into the B, you can see we've got populated our B plus, B7, B6, B5, B4, B plus, B7, B6, B5, B4, then our NC empty, then our NTC2 populated, and then our ground populated. And on this one, oh, get a little light, probably because there's a dead cell or something going on. We get our B3 minus, B2 minus, B1 minus, B1 plus, B1 minus. So that one there, the yellow, is our B3 minus. Then we've got our B3 plus, B2 plus, B1 plus, B1 minus. Then we've got empty, unpopulated, which will go to NC. Then we've got NTC. No, we haven't. We've got NC for this one. And then we've got NTC1 for that. Or I'm misreading it, but it'll be fine. So they are little LEDs on the board there. Now, are my suspicions about the cells accurate? Do we just have dead cells? You'll have to excuse my peasant's excuse for a multimeter. The battery died in mine. I don't have any 9-volt batteries. I'm not going to the shop. I've ordered some rechargeable ones from the interwebs. They're like USB-C rechargeable ones. Let's check out some voltages, shall we? We'll go from there to there. Okay. Right, okay. There to there. Please show me some voltages. Oh, there you go, 3.54. Hopefully you can see that. There to there, 3.53. There to there, 3.53. Okay, so they're all balanced, non-puff. That's sort of what I'd expect to see. And then we'll go from here to here. Nothing. Nothing at all on the puffed cell, completely dead. Nothing on that one, it would appear. Scrape off the layer on top, make sure it's not, I'm not just reading some corrosion. No, nothing there. This one we've got 3.56 and this one we've got 3.56. So it looks as though we've got two dead cells, the puffed up ones. kind of what I expected to see. Now, how am I going to get these hot glued devils off without exploding my fingers? I could get the cutters on there and leave it up and only touch one of these. Seems like an option, doesn't it? If I make sure I only touch one of these at a time, it can't explode me. Right? Right. Someone out there is going, just heat up the hot glue, it will come straight off. Where's the fun? Where is the fun in that? There just isn't any. Oh, well, all right. That's one way of doing it. Just rip it straight off the board. Sure, done. All I was going to do after I got that off was this anyway, so that's fine by me. That's that lot. And then I could just cut these one at a time. That is an option I could use, but where's the fun? So I'm going to rip the connector clean off the board on this side. Yes, I think I can, because it's wiggling that much. Yep, connector come off. Very good. It's just what I always wanted. And give that a big snip in the bin, and we've got our cell taps. Right, so next up I need to either find or build a 24-volt battery pack. So that would be a 7S something P. I might just do 1P for the sake of testing this thing. Oh, 1P will work, won't it? In fact, the most important thing I need to do is take this puffy monstrosity outside and away from my life. Okay, I have cells. Got cell holders, should have 14 cell holders, so I'll snap them together. I'll do, hopefully I could do 7S3P and that'll fit. Oh, will it fit? That's a good question, isn't it? Excellent question, sir. Excellent question. Will it fit? Let's keep those together so I don't lose them. That's got to be in there and that's got to be in there. I can hang out the end. Oh. It's not going to fit, is it? It'd be too easy. It'd be too easy. Let's move this lot into a tray. I mean, it might fit. What kind of depth are we talking here? Don't need to insulate it, do I? It's in a bloody great plastic case. Let me get my micrometer that's probably also out of battery. I seem to recall it was out of battery the other day. It was misbehaving. It's fixed itself. Very good. That's what I wanted. Let's see how deep case-wise we are. That says 34.5mm. And this side says 34.5mm. So if we double 34.5 is basically like doubling 35, which will take us to 70, minus a mil, so 69mm. Is this 69mm? It's bigger. That doesn't work. Bottoms. Okay. What about, instead of doing them that way, I did them that way. So it was 3P, 1, 2, 3 cells tall that way. So in the holders, that'll be that tall, which is exactly the same bloody height. Can I do it and just crush the case around it? Yeah, I think it'll be alright. I think it'll be just fine. Let's do this anyway, and then see if it fits. It's my favourite way. So let's get these together. 1, 2. That's so tight fitting. That's 5, 6. I'll put that one on backwards. I'll put it on backwards. Okay. 6 and 7. That's 7 of those. So I'll either fit that way or it'll fit that way, and I'm going to just make it work. So this will be these are 10 power 40 TG, so this could be a 12 amp power pack, not the 20 amp hour that it originally was, but I plan on using this as a car lift by a car jack, because it's a big powered forklift thing, goes up and down. Not forklift, pallet jack. And I don't want to buy another car jack. I've got a car jack here, but I don't have a car jack up at the unit where I work on my cars. I keep stealing my friend's one. Now, that's all well and good till he wants to use it. And check, you'll pump up a jack. This thing, you'll just be able to press a button. It'll be glorious. It'll be lovely. It'll be unbeatable. I will be the envy of everyone. Now, I don't actually know what the lift height is, because, you know, the thing doesn't currently work, which is not ideal, but, you know, it'll be fine. It'll be fine. Anyway, if it had 2 dead cells, of course it's going to throw an error. It probably works fine, and it was just the dead cells that were causing the issue. Okay, I got an extra 5. I don't have an extra 7. Otherwise, I'd have, you know, built one size up pack. But here we are. What do you want me to do about it? Put this lot together. I suspect that this machine can draw quite a lot of amps. But what I also suspect is that I will not be using it to its full potential. I will be prattling about with it and lifting myself up and down quite a lot and going, oh, look what I made, look what I fixed. And that's probably the limit of, aside from occasionally lifting up a car. I've got an old Beetle. You know, I do sort of classic car things. It's not going to lift up a Land Rover Defender or anything. This thing's only got a lifting capacity of 1,500 kilos, which for me, I'm not lifting up whole cars either. I'll be lifting up some of the car, like the back end or the front end, or, you know, one side, never the whole thing. So I won't actually be lifting 1,500 kilos. Probably. Okay, let's get all these facing the same way. Like that. Right, shall I see if the lid shuts? Obviously these tabs are sticking up currently, and they want to not be sticking up, but... well, that'll be fine. There's clearly room, because the battery pack should now be at the bottom. Yeah, see? It's fine. It's so fine it all came apart. It obviously wasn't bloody holding it. Oh no. So that will fit, which is nice. It's good news. Obviously, if you wanted to go custom cell holders or something, I'm sure you could do this way better. But I just want to see if this thing works. This cost me 50 of my finest English pounds on Facebook Marketplace. The guy wanted £100, and I said, would you take 50? Because lowballing people on Facebook Marketplace is one of my favourite things to do in the whole world. And he said, I would quite like 80, and I said, don't worry. And then he came back to me with, actually, I'll take 50. And all the times you lowball people, most of the time, tell you to do one. You know, if they're not interested, go away. You're rude. But occasionally that one, occasionally one person will say yes. And when one person says, oh, to live for, to die for, it's great. Right. Yep. I'm going to spot weld that together now. I'm probably not going to show you because it's way quicker if I just go get it done rather than set the camera up and tidy up that whole bloody side of the room, because imagine if this looks like this, imagine what the other zone looks like. I'll come back when this has bits of nickel on it. I've changed my mind and we're going to film a little bit of it. I've already done that side, but you know, why not throw in a bit of spot welding? Some people like to watch it, even though I'm just doing exactly the same thing repeatedly. But then I watch videos of people jet washing on YouTube, so you know, why not? I've got my welder turned up pretty high because this 21700 strip is pretty thick. I'd love to show you the screens, but it's decided it wants to go blank. But it's at 300 strength for pulses, I think, then 60 millisecond in pulse time. But unless you have this exact same welder, that will be, you know, bloody meaningless, basically. This spot welder is incredible, to be honest, for just speed and ease. Now I've started getting the settings a bit better when I'm using it. It's fantastic. Why would you ever use anything else? Done. That took really not very long at all. Let's go back over that way. We'll do some BMS wiry stuff. Okie dokie. Right. Soldering iron is warm. This is there. Let's get these tinned and BMS connected. Good for you, that. You want to breathe that in. It's there are no badnesses at all. It's fine. I need more solder. Here's some I made earlier. I'm gonna tin the living what's-its out of this bit. I should have done this before I spot welded it, I know. Whilst I may look and sound dumb, I actually do know some things. Because it's not even warm over here. I can hold my finger on it and not burn myself, so really I'm not actually putting very much heat into their cells at all. It was warm when I spot welded the bloody thing. But, you know, part of it, of course, is not leaving the soldering iron on it too long, because you don't want that. Okay. Right, before I go too much further, I'm probably going to want to insulate this a bit with some... Where's it gone? Where's it gone? I had a roll of green stuff. What have I done with it? It's there. You hid it from me. That's what you did. Right, that'll be really hot, so let's just touch that. Yep, very good. And we'll pop that on there, very nice. And we'll remember that this is the positive side here. I wish I had more space. One thing I wish for is more space. I know I'd just fill it up with more stuff, but it doesn't mean I don't want it. Now, I only did one layer of nickel. Realistically, it probably wants 2 layers of nickel, not 1. But I'm a bad person. So I'm giving it 1. This is not a customer build. This is for me. I'm not going to be using it in vast, prolonged use periods or anything like that. I'm just seeing if it works. Because if it works, I'll be a very happy man. Very happy man. Okay. Right, that is at least safer than it was a minute ago. Hopefully that'll fit like that. And the old bummus. Actually, that wants to be this side then, doesn't it? But then if it's this side, nothing fits. So really, I want to put that on. Why are you round there? Whose idea was that to put you round there? Can't you go not round there? Which is stupid. Can't you go round there and then just not be like that? Now, that's going to have to be that way. These aren't long enough. But they would be if I just snip that. Oh look, now it's more than long enough, so look, that will hopefully sit there somewhere. That will still plug in to, where do you plug in, sir? Mr. CAN bus, sir. Right down there, and then you'll be able to reach there. Yes, there's room, just, as long as everything's routed properly. But you won't reach. Okay, so you're going to have to live on this side. I shouldn't be doing that with that. That means there's room for that. Length on that, there's length on that, there's length on these, there's length on those because they're attached, and that will fit around wherever it fits. That's going to actually live up here, and that will fit like that, however that thinks it goes. That way probably, that way probably. Excellent stuff. Okay, so this all looks doable. So hopefully I can get the BMS fitted. Main positives up here. Let's mark that plus, and let's mark that minus. Excuse me, hiccups. Get the big soldering iron on, back on, because I didn't do that. I'm stupid. And let's start popping some leads on. That's got more than enough room. Yeah, this will be fine. I think I'm going to have to extend. This lot will be alright, but that lot was definitely going to be too short, so I'll have to extend all those, which is great fun. But I got these BMS wires I stole from different BMS, so that'll be fine. Right, do I want to put the BMS back together, or not? That's a good question. Because if it doesn't work, I'll need to get to it, but if it does work, it'll all be back together and I won't need to get to it. So what do we think? Let's just put it back together. It's only 4 screws. I'm sure I'll survive. Those 4 go like that. 1, 2 of them, 3. Come on. 4. I've lost my screwdriver. Found my screwdriver. Let's just say it's going to work. Let's be optimistic today. 1 screw. 2 screws. There's a bit of torque on that screwdriver, eh? 3 screws. The trick with the torque on the screwdriver is to hold the screwdriver really gently, so the screwdriver spins, not the piece you're working on. And then, you know, that works. Right. Put that back where it lives. Okay. Wires. Is this big soldering iron hot yet? Let's have a look. Oh, I've dropped the little soldering iron and it's melting. It's melting. It's melting things. And that's through my charge cable. Oh, goodness. Okay. Right. Freedom. Let's get these on then. Got our main battery positive cable to go on here. Just sort of thought I might strip and do in more places, but I can't be bothered, so I'm not gonna. That's not up to temperature, is it? Nope. What else can I do instead? Start stripping the ends of these. That's what I can do. Right, done. Should probably tin all these, really. Makes sense, wouldn't it? Now, there was a stick of solder. Is that all I have left? Is that it? Don't know. Tinned. These ones probably out of shot, but I'm just tinning some wires. It's not that exciting. The stick of solder is getting very short and very hot now. Ah, hot. I'm going to pick that back up actually. Ah, it's still hot. Okay, so let's pop that like that. Let's pop that like that. Okay. Alright. I've been called. It is time for me to go. Unfortunate for me, fine for you, because movie magic, you'll come back in a second, but in reality, much time will have passed. Oops. A ball of solder fell down and exploded all across the side of the pack there and shorted out. It's not what we want to happen. Right, that should be enough on there. We'll have some pliers. Some pliers. Oh yeah, that's nice that. Look at that, no dry joints here. No dry joints here. Not meant to blow on solder to cool it down, but sue me. But we use that bit. And then we got this one to go on. That's going to go around there, and then it's going to go on just here. Here will do nicely, won't it? Yes, very good. Oh, beautiful. Beautiful, 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 beautiful. Right, and then what we'll want to do is we'll want to get that like that. Get That's going to sit there somewhere. The BMS is going to mount there somewhere. So we're going to get this on there somewhere. Okay. Time to turn you over, Mr. Battery Man. That's what people call me, Mr. Battery Man. And we'll get that all on there. And where are my pliers? Pliers. Get our big main negative lead, and we shall. Must reposition. Must reposition. Nobody expects the Spanish reposition. Nope. I'm still not positioned correctly. Please don't short out. Well, that's terrible. It's terrible. I'll do it again. There we go. Unplug that if I'm not going to be in here. Seems wise. Oh, that's really hot. Right. I will come back. We shall finish this because I want to know if it works. And the pallet truck is sat on my driveway, and anyone could steal it. Okay. I was putting the BMS on here. I've wrapped just the sides now. Let's get these balance wires all hooked up. So we've got our B+, which is our main battery positive. I'll take that off, I don't need that. Get out of here. Get out of here, please. Why have I done that? Get out. Get out. Get out. Out. Right. So we've got our main battery positive. I'm not really interested in making this very tidy as of right now. I just want to know if the bloody thing works. So I'll probably wrap it up in kind of alright fashion and just call it a day. There's our main battery positive. Next up, we've got the next one down the line, which will be that one there. Yep, that's fine. And then we've got our next one. And then our next one. And then we've got our next one. Isn't this riveting stuff, ladies and gentlemen? That one there. Okay, now's the question. Are any of these going to reach? So obviously this will need insulating because it's all going to short out on these, but are these going to reach? You've got... That one will be the furthest. It's going to work. Oh! How exciting! I love not having to extend things. Makes me a very happy bunny. That's not great, but it'll be fine. Oh, I've got an extra wire. Why have I got an extra wire? Oh no. One moment, please. My brain is not computing. B plus, B7, B6, B5, B4, B3, B2, B1, B minus. B3, B2, B1, B minus. What? Hold on. B plus, B7 plus, B6 plus, B5 plus, B4 plus, B3 plus, B2 plus, do I have them on the pluses or do I have them on the minuses? Because B plus and B7 plus are the same. So this one also goes to there, I believe. Ah. Okay. I think that might be where the confusion has arisen. Is that these all need to be one further along than they are. Because, look, B7 here plus is in fact there. So these two go to the same place, it would appear. Bizarre, but not unheard of. Okay, that's fine, we can make that work. So this would be B6 plus, which is the same as B7 minus. Yep, okay. Okay, brain is doing brain things. It's happening, it's just taking its time. Brain. And then B5 plus is the same as B6 minus, because they're joined. Okay, yeah, I think I can get behind this. It's just bizarre. But again, bizarre but not unheard of. Odd. And then B4 plus, which is the same as B5 minus. Bet the cables don't reach anymore. I knew it was too good to be true. And then I dropped the other set of leads and they disappeared somewhere. Did they go in the bin? They're not in the bin. If they're not in the bin, we're... Oh! Dangling. Very good. So after that we'd have B3 minus, which is the same as B4 plus. Now will you reach? No. Unless you didn't sit there, you sat up there. That might reach if it was up there. Oh, we can make this work. We can make this work. It'll be fine. Yeah, it'll be fine. So that one there's B3 plus, which is the same as B4 minus, and then we'll have B2 plus, which is the same as B3 minus, 1, 2, 3 minus, yep. It's all very confusing. Oh. And then that one was going to go here. And that one's going to go to here. And then it's going to work. Right, theoretically they're all hooked up how they should be. So, I'll just need to insulate over these. Probably be by cutting some squares of fish paper. Paper of the fish. wasn't going for neat. Always said I wasn't going for neat. Just to see if it works. I mean, if it works, I'm going to be honest, I'm going to wrap this up and just keep using it, but, you know, it's just to see if it works. Okay, so that's on there, and then I can get that plugged into there, like that, and that does have enough room to sit on it, just. Yep, excellent. Right, charger. Is it going to charge? If it charges, it'll probably work on the device, but to activate it, it will need to be plugged into the charger. Oh, product placement. Let's have a look. Let's get that up there so we can all see. It's a big heavy thing, that. I'll show you the charger as well in a sec. Right, so charger's powered up, so red is charging, green is full or disconnect. It is a SANS SSLC300V29. So input 3 amps, output 8 amps. It's probably a bit much for this, to be honest, but again, for the amount that I use it, it'll be fine. It'll be fine. Didn't look at that. Let's see what it does. What way up does it go? That way up. It doesn't work. Oh, I don't have everything plugged in. I'm a fool. Oh no! I built the whole thing upside down. My can and my charger aren't plugged in. I'm an idiot. Can that actually just go that way up? Will it fit? Will it fit? Will it fit? Will it fit? It will fit. Okay, it will fit. There'll just be some jiggery pokery to do. Let's get the can plugged in and the charge port plugged in, because the charger does talkie-talkie to everything else. Now let's try plugging the charger in for the first time. Oh, flashy green light, flashy blue light. Charging! Stop charging. Charging! Stop charging. Oh. We've still got the flashy blue light on the BMS. But it stopped charging. I was a little excited then. Let's just unplug it. Now it's activated the BMS. See if the blue light keeps blinking. The blue light stops blinking. Plug charger in. Charging. Stops charging. Click. Click. Interesting. Interesting. Let's get our POV spec multimeter out. Let's see what it says. So, red to red, charge to charge. We're seeing 29.8 volts at the charger. On the output we're seeing 25.5, and on the battery side we're seeing 25.5. So it's not taking a charge for some reason. I could have the BMS wires round the wrong way. It is possible. That's a thing that I've done. Let's unplug the charger from the mains, let it power down, drain of all its juju. Okay, so now we're seeing sort of just battery voltage at the charge port. Let's try again. Charger on. Charger plugged in. Charger connected. Charger talking. Charge. No. Probably should have started charging, really. Let's disconnect that from that. The light's gone off. We want to down power the charger completely. 0 volts on the charger. Power up the charger with the mains, green, and plug it into the battery. Right, charging. Stop charging. .2. Now, is it actually charging? That's the question. It's worse. It's worse than it was. Charger's reset and plugging in. It does start charging, but then it stops. Oh, and then it starts again, and then it stops. Is it because the BMS has been all smooshed about? Is it not detecting me charge leads properly? This little blue light flashes, but that says coil. Unplug that. Plug that back in. No change. Unplug that. Unplug that as well. Plug that back in. Plug that back in. It worked a bit longer. Never was going to be simple, was it? I wonder if these two are connected to the right thing. I do wonder. I think they are. They're joined together with this little sort of tag that says BMSB. B plus and B7 plus are the same thing because there's only 7 groups of cells. Now what I have to do, I have to check and see what voltages we're seeing on these bad boys. Oops, and all my fish paper's coming off and just going to short out on my BMS, which is bad. It's not what we want. Let's try plugging in U first. Definitely seated correctly. Then use second. Any change? No change. Charger down powered. Charger powered up. Charger plugged in. Clicking. Charging. So I can definitely just use a BMS, different BMS to charge this, but it's the communication between this and the actual device itself that's important. And if it's not letting it charge, is it going to let it put out any power? I don't know the answer. Probably not, let's be honest. I wonder if these people exist. Hangzhou NEGT. I wonder if they can just sell me a new BMS. Let's see. AliExpress? No, Chrome. Hangzhou to any GT Co Limited. Specialised stuff. anygt-tech.com. Our services. Okay, they exist. They make BMSs. Theoretically, if I talk to them, they'll sell me a new one. Is now the time to investigate the funny soldering work going on this board, given the fact it won't let the thing charge. Ah! Lost. I haven't squished these pins here. No, they look fine. Ah. Is 8 amps too much and these cells are going to high voltage really fast, perhaps? Is that what's happening? 8 amps shouldn't get them to too high voltage that fast though, should it, really? Oh, 3.6, 3.7. No, nothing too crazy. Beginning to suspect this would have been easier if the board was all original. Thermal camera. Okay, seems like a good time for a thermal camera. And then we can check the cell voltages at the balance plugs. Something's warm there. not that warm. Seems sort of 29 point something. Interesting. Right, let's just short out some FETs and see what happens. There must be discharge. That's a charged FET there. So it can charge. It's not the communication, because the communication would tell the charger to stop charging. So it's something to do with the BMS being unhappy. Because if I short out the charge FET, it charges. There is some of the board that's sort of... Is that the board that's peeling off? It's hard to tell if this is a good job here. On the FET. So let's just add a bit of flux and retouch up a couple of these. Probably shouldn't do it while the power's connected, but I don't care, so you know, we'll be fine. I didn't do anything. It's interesting, isn't it? I wonder if the FETs are bad. you can't hear it on camera, but when I short them out and it starts charging, or when it starts charging by itself, it you hear after a couple of seconds the FETs start going zip, 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 sort of in like a bit of a I'm giving up sort of way. But the charge FETs shouldn't affect the discharge and using it on the device. Because I can use a different BMS to charge it, you know. That's a different charger, that's not a problem. I can still do that safely, just add a second BMS exclusively for charging. Possibly, is it time to look for any fuses on board? No, because it works sometimes. That looks like a dip switch. But it's covered in conformal coating. It is a dip switch, look. Interesting. Let's try just down power that. Down power that. Down power the BMS. Oh, now I start getting little lights. Down power that side of the BMS. I wonder if some of those weren't making proper contact. Because when I started wiggling them around, bloody things lit up. It's raining outside, which means my pallet truck and somebody's bicycles were getting wet. See, look, they light up now. How bizarre. But that stops them lighting up. You know, I wonder if this extra one's even supposed to be here. Let's just try disconnecting this cable. Try some different combinations of the balance leads and the way that they are. Just don't know if I'm happy with how they are, to be honest. Now here, look, no amount of shorting it out will make that work with that disconnected. With that connected, nothing. Oh, but without that connected, it charges? Or is it just pretending? We'll leave it for a second, it's probably just pretending. Faking it. It's longer than it stayed on before. Promising. Battery positive to charge. Oh, fucker's charging. Alright, we won't connect that lead. Obviously I can test this and make sure it charges up to full and discharges and the cell balancing and all that kind of thing works. But you don't connect that. Battery plus. Maybe there was a diode or something in there before. It's interesting. Or a resistor or something. Don't use that. It could have been not connected in the old plugs that I've thrown away now and can't check. But that's interesting. Okay, it charges. Fantastic. It's one step closer. Yep, it's charging. See how hot these cells get. I've got to go move some bikes in out of the rain, and I'll come back to this in a minute. Okay, I've left that for 2 or 3 minutes, and the battery voltage has in fact gone up. Let's try disconnecting the charger. Reconnecting the charger. Have occasionally seen these things where you have to get the mains out, let the power drain, and only then can you charge it. Let's see. Power to the mains, power to the battery, and charge. Nope. Cock. You know, I thought I'd got lucky there. I thought I'd done it. I hadn't done it. And stop. But if you disconnect that afterwards, then it does charge. Very strange. So it needs to be connected and then disconnected, and then it will start charging. There's something's not quite right there. To find those connectors in the bin, don't we? That's the one with 4 wires, so not that one. Why am I digging around in a bin? No one wants to watch me dig around in a bin, do they? Surely not. Did I even put it in the bin? Oh no, I did. Look, found it. 1, 2, 3, 4, 5, 6 pins because one was ground. The red one was that one there. So I'll go and find the battery and have a look. Okay, I've got that old battery pack here. I've got my connector, which I think would have sat that way round. Pad there, pins pointing that way, and I ripped the pads off, yep. So let's see where these think they go. I'm after the red one and the yellow one next to it. So meter in beep mode. It beeps. So between what's left of this pad and here, beep, beep. This pad goes along here, around here, and somewhere. it goes to B7 plus. So that's the same as, so I've got B5 plus and B6 minus are the same thing, and that goes round here and to the same pad as this. They go to the same place, so something's not happy with this. Oh, I killed it, see? How did I kill it? What did I do? That's interesting. Did I wiggle this thing that the man touched? The man before me, the previous man. Because there is that damage to the back of the board as well, that I haven't scraped away at and investigated. Resolder that back on. Have the charger out. Have the charger in. It charges. BMS is throwing a wobbly. Chip looks okay. It's odd that only as I start unplugging all this stuff do any of these little lights light up. See, look, this will light up. But never do I get any lights on this side. I get a flash, but it seems unhappy. Unless I disconnect this. So as soon as there's battery positive power going to any of it, it all stops. I get the blinky light. But that goes out. Is that telling me what's missing? Perhaps. That's telling me something isn't connected, so that's the bad cell. Because these are the same thing. Let's try disconnecting a different one. We can prove our theory then of what they do. No, because all these are disconnected. So I know you're pretending to charge. You'll stop again in a second. Yes, very good. Right, looking at the back of the board then, you've got whatever on earth has happened to this. I wonder if we're not feeling too hot about all this. I'll do this with the cells connected because if it explodes it'll be really funny for the camera. Stop that. Is this just ground plane that's been scratched off? I wonder if it is. Undo you. Undo you. I'm going to stop recording and I'll update you if I get anything good. I probably won't. Probably knackered. Okay, so we've descended into some form of bodgery because the battery ended up with being a bit too thick and a second battery management system in parallel with the existing one. So the first battery management system, the original one, is used for discharging and CAN bus, but I'll get to that. And the second battery management system I put in there is only for charging, to make the charger work, but the communication from the charger is still going to the original BMS. Very confusing. I think if you didn't have a broken BMS, this would all be fine. You just replace the cells, easy peasy. So all the ports are the same. It fits back on. Just about. It's a bit tighter than it used to be because I've made it the wrong size, but that's on. And then it comes up with, oh, it's my secret code. It's definitely not 1, 2, 3, 4. That's the hours 33 and 83. Can't remember what 33 is, but it doesn't matter. And 83 is CAN bus between this and that. I'll put a link to the PDF on the manual for this. It's not only a Doosan, it's also a whatever else it is. I'll put the link to the manual in there. Very helpful for seeing what all the error codes mean. You could probably look up what 33 is. Now that it's on, what seemed to happen is it would lock out the lift. You could move it forwards and backwards with the CAN bus error, so the battery's not communicating to this thing. But at the moment it goes forwards, backwards. The safety lockout thing works, so if you were going backwards and it hit you, it goes forwards instead, so it doesn't squish you, and then it's locked out until you lift the arm up, put the arm back down. So go back towards me and oops. Oh, well, I can't press it at the same time, but that probably works. Then for lowering, that's always worked. So you'd be looking at it this way up. Lowering lets a bit of hydraulic pressure out, goes down. That always worked. It never locked that out. What it did lock out was the up. Originally, the up was controlled by, it's my pokey screwdriver, this solenoid here. and there's CAN nonsense going on, but it's always got positive power going to it on the, not that one, this one, which is labelled something I can't remember, and the controller gives it a ground, so it gives it negative, bit like a car ECU. So this one here is the one that power now flows through. We've got KSI, key switch input, not the YouTuber, 3 minus. They all go to here, they're all positive power. I've taken the one side of that coil off. It goes to the limit switch, which is here. It goes out of the limit switch, so the limit switch is normally closed, and it goes open when that is pressed up. It then goes into this, into my wire here, which I've run an extra wire. I should have really run it down there, through all its gubbins, back up and everything, but I didn't because I'm lazy. It now comes out of here, up here, and it's soldered directly onto the back of that button there. No, that button there. So the only thing we ended up having to bypass was that. Everything else just works, which is pretty good. So even if you lose CAN communication, you literally bypass that switch and it's fine. Because that's just a push to make switch. So you push it, joins the two wires together, and then I wired it through the limit switch so it was still safe. So if we watch it while I lift it, there's a limit switch there, hits the switch, and no matter how much I press that, it doesn't work. But I can let it down, and then I can go up until it hits the switch, and then it cuts it. Doesn't let me use it. Down, up. This thing, for anyone that wants a model number without having to open it, is DC motor control. It's a Curtis 1212C 2503 24 volt 90 amp, which is many amps. Dead spider. Lovely. That looks like the Curtis controller port there, which, oh, funny enough, I've got a programmer for this. That's interesting, isn't it? Huh. More you know. I had to cut them off. They weren't playing ball. But basically, it all works, which is very exciting. You've got your battery positive, battery negative, which is what I tapped into to give the ground, or the negative to the lift pump. We've got our motor negative, motor positive. These are to the electronic brake. Can't remember what they do. J1-3 used to go to the lift pump, and it doesn't anymore. What else? That's kind of it. Hydraulic oil tank is there, and it, you know, uses oil. I think that's about it. Emergency stop button still works. Code still works. It just flashes an error up on the screen, and it's all functional, which is pretty cool. And of course the charger works now. But yeah, very good. Thanks very much for watching. If you like this sort of thing, if it was interesting, you can like the video, comment on the video, share it, subscribe, all that fun stuff. And I will see you next time. Bye bye.